Student, today I have defined you the convergence of secant method. Yes, assuming that fx, f dash x and f double dash x are all continuous functions in the neighborhood of the root x is equal to alpha of the equation fx is equal to 0. Yes, let f dash of alpha is not equal to 0. Now we can show that if initially x1 and x2 are chosen sufficiently close to x is equal to alpha, then the sequence xn converges to x is equal to alpha, and the order of convergence is approximately 1.62. Yes, approx. Yes. So let us suppose that let xn minus alpha is equal to epsilon n, and also from the formula of the secant method we also know xn plus 1 is equal to xn f of xn minus 1 minus xn minus 1 f of xn divided by f of xn minus 1 minus f of xn. Yes, and now as you know xn minus alpha is equal to this one, so xn plus 1 is equal to epsilon n plus 1 plus alpha. So from here you can say that this implies that alpha plus epsilon n plus 1, yes, this is equal to alpha plus epsilon n f of alpha plus epsilon n minus 1, substituting here from here, yes, minus f minus xn minus 1 in place here, alpha plus epsilon n minus 1 f of alpha plus epsilon n, this whole divided by f of xn minus 1, that is f of alpha plus epsilon n minus 1 minus f of alpha plus epsilon n. Yes, substituting all the values of, as you suppose xn minus alpha is equal to epsilon n. Yes. Now this can also be written as, yes, or this can be written as epsilon n plus, this can be written as alpha plus epsilon n f of alpha plus epsilon n minus 1 minus epsilon n minus 1 f of alpha plus epsilon n, this divided by f of alpha plus epsilon n minus 1 minus f of alpha plus epsilon n. Yes, if you taking the multiplying this thing, then you get the again this one. Yes, alpha is here and alpha is here, so it is cancelled out, so you become epsilon n plus 1. Yes, or epsilon, yes, or epsilon n plus 1, yes, this is equal to, yes, this become epsilon 1, and now expanding this term to the Taylor series, so epsilon n, yes, f of alpha plus epsilon n minus 1 f dash alpha plus epsilon n minus 1 square by factorial 2 f double dash alpha plus up to so on, and also here minus epsilon n minus 1, and here is again f of alpha plus epsilon, so f of alpha plus epsilon n f dash f of alpha epsilon n f dash alpha plus epsilon n square by factorial 2 f double dash alpha plus up to so on. This whole divided by this whole divided by this thing. You also here apply the Taylor's theorem, that is f of alpha plus epsilon n minus 1, yes, f dash, yes, f dash alpha, yes, plus up to so on, and also here f of alpha plus epsilon n f dash alpha, now so on. Yes, clear? Now here you say that as f of alpha is equal to 0 and also f dash alpha is not equal to 0, yes, you have chosen here. So from this here you see f of alpha is 0, so here become epsilon n minus 1 f dash alpha plus epsilon n minus n square divided by factorial of double dash alpha. Here is also epsilon n becomes 0, so the term start from here, epsilon n minus 1 epsilon n f dash alpha. Here and here is the same step, here is plus minus, so this is cancel out, and now the term become from here, and also here f of alpha, this is 0, this is 0, so f of epsilon n minus 1 is here, f dash alpha, and here is also epsilon n f dash, so dividing whole expression by epsilon n minus 1, this one, okay. So here is become this multiplied term here, and now you get this one, you get half of epsilon n minus 1 f double dash alpha divided by f dash alpha, because you dividing the numerator and denominator by f dash alpha, yes, you get this one, plus order of alpha n, sorry, epsilon n, yes, epsilon n square, okay. So let us suppose that this be as half of m, or you say that you suppose that half of f dash alpha and divided by f double dash alpha and divided by f dash alpha epsilon n minus 1, or we say that this is equal to capital M epsilon n and epsilon n minus 1. Yes, clear? Yes, you can write down, yeah, this is the term for the epsilon n plus 1, okay. Let us suppose that this equation number is 2, yes, here you suppose that is this is the formula, which is equation, this is the formula, you have to suppose that the equation number 1 and this is the equation number 2, okay. Now we have to find out actually the rate of convergence, yes. So where m is this one, yes, where you know that m is this one, yes, in place of this one, this is m, yes, clear. Now this shows that the rapidity of the convergence. Now we wish to determine a number p such that epsilon yes, from here substituting here. Yes, we can see. Okay. From here. Epsilon n plus 1 is equal to C epsilon n to the power p. Yes, satisfying the equation number 1, that is the formula for the secant method. Yes, okay. Since this is equal to C of epsilon n is equal to this one, so we get epsilon n is equal to, yes, this epsilon n is equal to C, yes, epsilon n, here in place of n plus 1 you can write as the n, so n minus 1, so here is n, here is C, and here is epsilon n minus 1 to the power p. Yes, clear? Now hence epsilon n minus 1 is equal to this one, is equal to this divided by C, that is C to the power minus 1 by p, and also epsilon n to the power, yes, we expression here dividing here, so epsilon n to the power 1 by p. Yes, clear it? Okay. Now using these that we have obtained C, yes, or C, that is you substituting here is as epsilon n plus 1 is this one, and also from here you supposing here is epsilon n plus 1 is this one. Yes, so substituting from here, from equation number 2. Okay, so therefore from equation number 2, and you can say that from equation number 3 or equation number 2 and 3, yes, equating these equations from these equations. Okay, C, yes, epsilon n to the power p, that is from here. Yes, okay, from equation number 3, and also equation number 2, this is equal to m, yes, epsilon n is where, or in place of epsilon n we substitute this one, that is C to the power minus 1 by p epsilon n to the power 1 by p. Yes, okay. Now comparing the coefficient, comparing the powers of epsilon n to the power this one and epsilon n is 1, yes, plus 1 this one, that is, this implies that p is equal to 1 plus 1 by p, yes, or you say that p square minus p minus 1 is equal to 0, or p, the approximate value p is equal to 1 plus minus of under root 5 by 2, yes, this one, or you say that, and here is the value are 2 are 1 plus root 5 by 2 and 1 minus of root 5 by 2. Since 1 minus under root 5 by 2 is a negative number, so we have obtained p from 1 plus under root 5 by 2, which is approximately, yes, 1.62. Yes, hence we can say epsilon n plus 1 is equal to, is approximated to, from equation number 3, yes, we have to supply epsilon n to the power p, and p is 1.62, yes, and c is also multiplied here, so c. Yes, clear? And thus the sequence, thus the sequence xn, yes, converges with order 1.62 approximately. Thank you. I think you have to clear it. Okay, next video I will tell you the other, some other different type of the